Hi, everybody. I'm going to go ahead and re-explain some of our points to an equation and what this is actually useful for in the real world and how it applies in the real world. So we've got a couple of data points, and in order to find the mathematical model for these, we go through some steps. The first step is to go ahead and find the slope. So find your slope for these 2 points, and everybody should find it. The slope, of course, is equal to the difference in the y's over the difference in the x's. And you should substitute in your y2 minus y1 over x2 minus x1 and reduce your fractions to lowest terms, and you should find the slope. So that is your first step. Now, when I substitute this in, I have 2 options. I could subtract it with this one as 0.2, or I could choose this one as 0.2. It doesn't matter which one you choose first. Because I have a positive 8 and a negative 7, I'm going to choose to do this. 8 minus negative 7 over. Now notice I took y2 minus y1. Very important idea. I also am going to take x2, which is negative 2, minus x1. Now, what's important is that you go in the same direction. It doesn't matter which one you choose first or second. That's 8 plus 7, which is 15, over negative 2 minus 4, which is negative 6. Now, this is the same thing as if I went the other direction. I'm going to go ahead and rewrite these so that it's a little neater. If I had gone in the other direction, I would have gotten negative 15, over positive 6, which is the same thing. Both of these 2 slopes are exactly identical. This one says go up 15 and back to the left, go up 15 and go to the left 6. This one says go down 15 and go to the right 6. They're both the same. This can be reduced to negative 5 over 2. I divided by 3 in the numerator and the denominator. Now I'm going to choose a point and substitute the point and slope into my equation, y equals mx plus b. Now I need to, the slope is right there, but I need to choose one of these 2 points. It doesn't matter which one you pick at all. So for whatever reason, I'm just going to pick this one. And what I'd like you to do is substitute it in to y equals mx plus b. So you're going to take your point, negative 2, 8, and your slope, negative 5 over 2, and substitute it into the equation, y equals mx plus b. And then you're going to simplify and solve the equation for your y-intercept value, which is b. So do that. Don't wait for me to do it. You're going to substitute in your y value, which is negative 2, equals m, which is negative 5 over 2, x is 8, plus b. And you're going to solve for b. So simplify and solve for your y-intercept b. You have 2 options. You can multiply the negative 5 times the 8 and get the negative 40 over 2, which gives you negative 20. That's fine. You have another option, though, and that is you could, if you wanted to, what I do? Oops. Really easy to make a mistake. Sorry, guys. God, I'm a spaz. I put it wrong. That was not my y. That was my x. I got confused because all day I've been doing the point with negative 2 as being the y value. Anyway, my y value is 8, is equal to m, which is negative 5 over 2, and my x value is negative 2 plus b. I could pretend like I did that on purpose, but I didn't. What I'm going to do next is I am going to simplify and solve it. So I'm going to simplify it. -5 times -2 is 10 over 2. And 10 over 2 is just 5. I'm simplifying nice and slow. And my last step is to solve. I'm going to subtract 5 from both sides. And I'm going to get my b is equal to 3. Now I'm going to write my equation, and it's going to be my mathematical model. Let me move this up just a little bit. This is step 4. And I can write my mathematical equation. Y equals, and this is going to be -5 over 2, x plus 3. Now I could have used my other point. I could have used the 4, -7 to do this. But what I can do now is I can test my equation by using that point to test it. My y is actually -7. And -5 over 2 times x is 4. And if I add 3, this should be true. This is -20 over 2, or -10 plus 3, which is indeed -7. So this is the right equation. Now what I'd like to do is be able to use my model to make a prediction. So what would happen if x was equal to, say, 8? What y value would you get for that? And I want you to think about how you could use the equation right here to make that prediction. And we could substitute the +8 right here for x and find our y value. So y is equal to -5 over 2 times 8 over 1, if you like, plus 3. And the 2 cancels with the 8 to give us 4. -20 plus 3 is -17. And we have a prediction at that point. Okay? Well, that's the first steps to this, and I'd like you to do one of your own. So the one I'd like you to do on your own is this one. I'd like you to find the equation through these 2 points and use that equation to fill in these missing values. So remember the 5 steps. Remember, step 1 is to find the slope. Then you're going to substitute it into y equals mx plus b. Hopefully you'll choose the easiest point. I would say that 6, 7 might be the easier of the 2 points. And then you're going to solve for b. And then you're going to write your equation, y equals mx plus b. You're going to put the m and the b into your equation. And then you're going to use your equation to find the -9. You're going to substitute that in and find the y value that goes with that. And then you're going to substitute the -1 for y and get that one in. So do all that and find your solutions. Your slope is equal to 7 minus 4 over 6 minus -3. That's going to be 3 over 9, which is 1/3. And then you're going to choose a point. And we have y equals mx plus b. And you're going to substitute that point in. This time I'll put the 7 in the right place. The 7 is the y. The m is 1/3. The x is 6 plus b. And we simplify this piece right here. And you're going to get 6 over 3, or 2. And you subtract the 2 from both sides. And we have our b. You could have done some canceling right there just so that you saw that that's still 2 Still the same thing. Now we could, if we want to, write the equation y equals 1/3 x plus 5. And we have two problems that I would like you to solve. I want you to predict what value of y will I get if I put -9 in. So you're going to substitute -9 into the equation and find your y value. But we're also going to find what happens when y is -1. And over here, I want this one. So I'm going to substitute 1/3 times -9 plus 5, and that's going to be -3 plus 5, which is 2. This is y, isn't it? Sorry, I should have written that from the beginning. Now, this one, I'm going to start with my equation, y equals 1/3 x plus 5. And this is substitution. Instead of y, I am going to put -1. And then I'm going to solve it. Now, a lot of people would multiply everything by 3, which is fine. You can multiply both sides of this equation by 3, and it'll eliminate your fraction, and everything will work out. Your other option is to subtract 5 from both sides, and you're going to get -6 is equal to 1/3 x, or x over 3. Now, the problem is that a lot of people are going to want to divide this or multiply it by 1/3 or divide it by 3. But you need to divide by 1/3. Remember, dividing by a fraction is the same as multiplying by the reciprocal. I am literally going to multiply by 3 over 1, which is the reciprocal of 1/3. If I do it on one side, I have to do it on the other side. Sorry, it's a little messy there. Now that gives me -18 is equal to 1x. So -18 gives me -1 for my y value. So we have our two solutions. Now the reason we're doing all this is so that we can solve real life problems. And this is an extension of the problem I did yesterday. And it says, at 66 feet of depth, a diver experiences the pressure of 3 atmospheres. That's 3 times the pressure that you would feel standing next to the ocean. The reason we feel air pressure and the reasons that we don't blow apart is because our atmosphere has a weight on us of about 17 pounds per square inch. And it holds us together and keeps our blood from boiling, does a lot of nice things. So we have air pressure around us because we have so many miles of atmosphere above us. But when we get into the ocean, at 66 feet of depth, we're feeling the pressure from 3 atmospheres because water is much heavier than air. It's only 66 feet of water, but 30 or 40,000 feet of air. So there's a big difference there. Anyway, at 66 feet, we are feeling 3 atmospheres of pressure. At 132 feet, you know what? I'm going to write it next to it so I have some space to work. At 132 feet, we are at 5 atmospheres of pressure. And what we want to do is come up with a model, this is a linear model, to predict how many atmospheres of pressure Jaden experienced on his deepest job at 621 feet. So we're going to find the slope, we're going to hopefully interpret it to make some sense of it, and then we're going to use that model. Once we get our model, we're going to use it to predict how many atmospheres at 621 feet. So do that, find your slope, and see if you can interpret it. It's going to be 5 minus 3 over 132 minus 66. And this is 2 what? Over 66 what? What do these represent? Well, remember that the enumerators are the change in Y's. Weren't these atmospheres of pressure? And these X values are feet of depth in the ocean. So this is feet. So if I reduce that, that means that I have 1 atmosphere of pressure for every 33 feet of depth that I go through, or that is above me. So now I want to solve this equation. I want to choose one of my points. I'll choose the easy one. And I'm going to write y equals mx plus b because I want to create my model. And I am going to substitute. What's my y value? Well, this time it's 3, and it's equal to m, which is 1 over 33, times x, which is 66, plus b. Well, 33 goes into 66 2 times. And b is equal to 1. And let's see if that makes any sense. If I'm not in the water, I should be feeling 1 atmosphere of pressure. That means that if I'm at 0 feet in the water, I should have 1 atmosphere of pressure right here, right where I'm at. And sure enough, that's the case because the air is the thing that's causing this, not the water. So my equation is y equals 1 over 33 x plus 1 atmosphere for the air pressure. There's your model, your mathematical model, and I would like you to make your prediction. How many atmospheres of pressure did Jaden feel on his deepest job at 621? Now, this doesn't work out exactly even. The only way it would work out even, I think, is at 627 feet. So I'm just going to go ahead. Even though the 621 was the actual depth at deepest, I'm going to go with 627. So we're going to overestimate just a little bit. So go ahead, substitute it in, and find out how many atmospheres that is. And that's it. We're done for our practice. Oh, wait, gotta stop.